Okay, some examples about the stack where we can see about the parenthesis matching. So this is the algorithm. So this is the pseudocode. Okay, so if you still remember the pseudocode, this is to explain briefly about the algorithms in Python. So we are using the stack. So if this parenthesis is in the opening group symbol, then let's push. But if it is not in the opening group symbol, then we need to check whether it is a closing group symbol. If it is a part of the grouping, the closing grouping symbol, we need to check whether it is empty or not. If it is empty, then of course it is false. So there is nothing to match with. Or yeah, we can just pop. Okay, pop means we remove. If we remove, and then we need to check whether it is matched with the xi. So the xi is the element in the index I. If it does not match, then it is also false. So this will be a loop until n minus 1, and once it is empty, so if the stack is empty, then yeah, we'll return true. So it means every parenthesis already in the correct order. So if you take a look on the stack section, this is the code. So this is the code. Okay, we already learned about the lefty, righty, and then if the righty index C is not the same with the lefty index S pop up, then it is mismatch. Yeah, this is the algorithm. And the application is available in the, okay, this is the algorithm in Python. So the algorithm of the stack or the matching, okay, the parenthesis matching can be found in HTML tag matching. Maybe some of you already know about HTML, but maybe many of you still do not know about the HTML. So I can explain briefly. For an HTML, or this is the hypertext markup language. This is the basic programming language for the web. In the web, you can have the tag. The tag means something that you can start and you can end. For example, if you are in the web page, you need to define body. And then you need to finish or you need to complete with the slash body. So this is the rules in creating the language in HTML. And let's suppose you have a definition about center. So it means, yeah, all those things will be in the center. And then if you have H1, it is header 1. And then you will have like the closing of the H1. And then, yeah, you will close what will be in the center. So the little boat, this is the text that you want to print in the web. So this is the result. It will be in the center and it will be in the big size because we are making the header. So the P means the paragraph. So we create a paragraph and the paragraph starts with P with this triangle bracket and then ends with the triangle bracket plus the slash. So we can also have another kind of tag like OL, which is order list, and LI, it means the list. So we can have like this 1, 2, 3. So it is like a list. So the first, the second, the third. So every of this red color should have the beginning and ending. So there should be a name, and then there should be the last name, which is about the name with the slash. So we call it, this is pair matching. In order to do that, then we need to make one algorithm to match the tag. Okay? So we call it, this is tag matching. You can see on the, yeah, this is the algorithm is match HTML and then raw. Raw means, yeah, any input that we can give. For example, if it is a string, then you can just define this is as a string, and then the string will be the information in this function. So you will start with S, which is an array stack. So we already defined the array stack. And then for every tag, yeah, we will start with the triangle bracket. This one. And then, yeah, it will do for every text that we have. Let's say, for example, we have this HTML, and then we finish with the slash HTML. So we will do loop. Yeah. So J means the index, which is not -1. We know that the index starts with 0. So it will be never -1. So if it is -1, it means we already reached the last one, or we cannot find. Okay. So if it is -1, then it means we cannot find the starting or this triangle bracket. So this will be always never be -1. Okay. And then it will be a loop. So whenever we find this triangle bracket, we will add the J, okay, and we will check whether the K is -1 or not. Again, if we cannot find, then this will be -1. But if we can find in the text, then it is more than or equal to 0. So this tag, yeah, this is a string, and then we can use a method or a function from string, which is start with. So if the string, okay, so we call this is the string, start with the slash, okay, then it means, yeah. Oh, sorry, if it is not, okay, if it is not started with the slash, then it is an opening tag. If it is not this one, then of course this is closing tag. And then again we will check whether it is empty or not. If it is empty, then it is false. It means for every closing tag, there should be always one opening. And then we want to find for any tag from 1 until, yeah, the end. And then if the particular index, when we pop it, and then if it is not the same with this particular index, then return false. So it means we are mismatch the delimiter. So the next will be again finding the J. So we need to find the other triangle bracket. And after we find it, then we will put the K equals to K plus 1. So the K will be added by 1. And then we will keep looping again until J minus 1. So J will be -1 when you cannot find any of these triangle bracket. Okay. So if everything in the array stack is empty, it means all the tag has been checked. Okay, so we already checked all the maths, and because it is maths, then we finish. So it means it will return true. Okay. So I guess I can start this one, array stack is maths. Okay, I will run this one, and it's maths HTML. So the result is true. Okay. And how about if I run this one? The result is false. Why? Why the result is false? Anybody? Why the result here is false? Yeah, I'm still waiting. Any comments? Okay, that's true. But here, so because this is a pair. Okay, so if we start with HTML, there should be an ending with slash HTML. We start with HTML, but we end with body. So it means this is not correct, or this is false. If you have this one, okay, the result is true, because we have HTML and then it ends with slash HTML, and then we have body and then we end with slash body. So this is how to get the matching in the HTML. So if you see this one, tag, okay, so tag means the tag means we want to find any string between j plus 1 until k. So if it is HTML, then there will be 4 letter HTML. Okay. So it means it will start from j plus 1. J plus 1 is from the beginning, the triangle bracket, until k. So k means the index of the triangle bracket for the closing. So this is any kind of word, because in the HTML, you can use like center. So it means there are 6 characters. H1, it means there are 2 characters. Or P, there is only 1 character. So the number of characters will be different. That's why we need to find the ending, okay, this triangle bracket, the ending of the triangle bracket, and then we will like to find the index, which is j plus 1, and it will be starting point j plus 1 until the end, which is the k. So the same with this one. So we will do for every of this tag, okay, until we can, if it is not true, then yeah, we just return false. So it means this is the tag or the text inside of this triangle bracket. Okay. Next is about how to evaluate the arithmetic expression. So in the mathematical expression in programming language, we call the operator precedence. So this operator precedence is almost the same with other programming languages. So if you learn like Java or if you learn C, okay, so they have the same like operator precedence. It means multiply, it will be the first compared to the other like plus or minus. So usually multiplier and then the division. Okay, this will show the higher precedence. The precedence means like the priority. So if you have like 4 multiplied by 3 plus 2, what is the result? Maybe your idea is from the left to the right. Okay, so it means 12 plus 2. Okay, this one is 14. Okay, but what about if I have like 3 plus 2 multiplied by 4? What is it? 3 plus 2 multiplied by 4. In this case, we will start with the multiplication. So 2 multiplied by 4, which is 8. And then after we have 8, we will do the summation with 3. So the result will be 11. Okay. Maybe some of you may think that why it does not show 3 plus 2 multiplied by 4. So it means 5. 5 multiplied by 4, it is 20. Why it is not 20? But why it is 11? Because in programming language, we have what we call as the precedence. Okay, so this is the priority. Okay, there are many correct answers. Okay, thank you. Oh, there are many students who understand this concept. Okay, thank you, Chan Sujong, Park Songan, Dong Yu. Okay. Oh, multiplication, division has the higher priority than plus or minus. And then if they are in the same level, then you will start from the left. Okay. But you can also consider like this one. Operators of the same precedence group evaluated from left to right. So for example, if you have 4 multiplied by 3 multiplied by 2, okay, then you will start from the left to right. Okay. Or if you have like 4 plus 3 minus 2. The minus and plus is in the same group, so it will start from the left to the right. But it will be different if you have like 4 plus, and then you put parentheses, for example, 3 minus 2. So this will be higher priority. Okay, so the parenthesis will be higher priority. So it means we will get 1 and then 4 plus 1. Okay. So this kind of procedure can be done with stack. So the idea is we need to push the operator on the stack, but first pop, so remove and perform higher and equal precedence operation. So if you have like this problem, actually we will do this multiplication first. This is 6, and then 14 minus 6, which is 8, and 8 plus 7. So the result will be like 15 for this problem. Okay. So this is the algorithm, how to evaluate a mathematical operation. So maybe you think, oh, it's very simple. Why it takes very complex algorithm? Yeah, because we need to understand the precedence. We need to understand what is the priority among the operations. So if there is multiplication and plus, then we need to make the multiplication as the higher priority. And if we have a parenthesis, we need to put that one also the higher priority. So we need to design the algorithm. We can use two stacks. We need to have the first stack is the operation stack, and the other is the value. Okay, so OP means operation, and then val means value. Yeah, I don't see this one as important, so just it is to express the end of the input token with lowest precedence. Okay, so we can have several functions. So this is the do operation, and then there will be another function which is repeat ops, okay? And there is another function which is how to evaluate the expression. So using those three, yeah, we can see like x is pop, y is pop from the value, and then OP means the operation. So if we already extract this x and we extract the y and we extract the operation, then just push to the value, the new value will be y operation x. Okay. So for example, if you have like 5 and then 6, and then the operation is plus. So the next value will be 5 or 6 plus 5. And we want to push into the stack. Okay. Repeat operation. So if the value stack is greater than 1 and the precedence, so the precedence of the ref op, so this is one parameter, this is less than or equal to the precedence of the operation stack on the top. So if those conditions are true, okay, then do operation. So we will do this one. But if it is not true, then we will stop. So this is the algorithm to evaluate the expression. So this algorithm starts with while. So while there is another token z, so it means we will separate every number with token. For example, if I have 5 plus 6, so this is one token, this is another token, this is another token. Okay. So if there is a number, there is still a token. So here there are 3 tokens. So we will check, is there any token? Yes. Then we will check whether it is a number or not. The first token, is it a number? Yes. Then let's push into the stack. And then, yeah, we will do this one, repeat ops. Okay. Oh, sorry, this one is in the loop. So is it a number? Yes. And then push. And then is there any other token? Yes. So the second token is operation. Is it a number? No. Then repeat ops and then push the z into the stack. Okay. So repeat ops means we want to find whether the value is greater than 1 and the precedence. Okay. So the precedence of the operation is less than the operation on the top. Okay. Because in the top there is still no operation stack, so it's empty for the first time, then we just push it. And then, and so on, we will return all the values after we do this repetition. And yeah, we will give the last value, which is in the top. So if I can say something about this algorithm, like this one. This is the value stack. Oh. Okay, so maybe I can say this is the stack 1, okay, and then this is the stack 2. Okay. So the stack 1 we will start for every token from the left, okay, and then once we have this 14 and then less than equal, okay, because less than equal is the operation, it is not the operator, not the mathematical operation, just it is a condition. So we will start with 4. Okay, so 4, it is one token. It will be saved into this S1, and then no, sorry. So the first is 14. It will go to the stack, and then the less than equal, it will go to this operation stack, and then 4, it will go to this stack, and then minus, it will go to this stack. Okay, so we have 2 stacks. The first is for the value, and the other is for the operators. And after we have this one, can we do something about this? So can we check the precedence rule? Yeah, because this one is the last one. Okay, so based on the precedence, we can say this is the less priority because we will need to do this one first. So we need to calculate the mathematical operation here to find whether the left and the right is comparable or not. Okay. So we will continue because it is still not in the priority list. We will continue. We go to the 4, and then we will go to the next, which is the operator start, which is multiply. We put here, okay, and then we put this number or the value into this value, and then we will check with the next number, which is 2. We will check with the next number, which is 2, and then we will compare with whether this is higher or not. So when we want to include the plus into these operators, because we know that the top, this is multiply, is higher than plus. Okay, then we will do the multiplication. We know that this is higher than the plus, so we will do the multiplication, which is 2 multiplied by 3, and the result, the new result, will be saved into this stack. It is 6. And then after we have this, we will go to the next step, which is placing the positive or this plus into the into this stack. But before we want to input this positive, this plus into this stack, we know that plus and minus is in the same order. Okay, so if it is in the same order, we need to start from the left. So if it is starting from the left, then we need to do this operation first. So for minus 6, it becomes minus 2. We save the minus 2, and then after that, we will save these operators into this operator stack. So we have the -2 plus, and then yeah, we still have one remaining token. The remaining token is 7. So we put this 7, and we need to check, is there any other token here? We just define the $sign to say that it is the end of the token. So there is no other token. Because there is no other token, so this will just be the stopping of the checking for the value. After we do the next, we can just do the 7 plus -2, and we will get the result. The new result will be 5. And then we have this operator, which is the less than equal to 14. Okay. And the result, the final result will be false, because we want to check this one, whether 14 is less than 5 or not. And this final result will be F. Okay, so that's the step by step to understand how to calculate this mathematical operation with the stack. So the stack can be used also for the how to do something for example, checking the stock. Okay. So nowadays, we can see there are many people who are interested on checking the stock, the market stock. Yeah. So we can use stack, and the stack as an auxiliary data structure in algorithm. For example, given an array of x, given an array of, okay, I missed this one. Okay. We call it span as I of xi is the maximum number of consecutive elements xj immediately preceding ij, such that xj is less than xi. Okay, it might be difficult to understand this explanation, but what I can say something easier is like this one. So I want to know how many times the number of stock is growing. When it is growing, plus, 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 plus. But when it is dropped, we return back to 1. Okay. Now you can see here, the price of the stock is high. Okay, because it is the first, so we just put this one as 1. It goes down, then yeah, we don't have interest on this stock because it goes down. So we just use the number 1. Okay. Now the next time, okay, so this is the time. In the next time, so the stock price is rising. Because it is rising, then yeah, we plus with 1. Okay, now it is increasing. And then again, this one is increasing. So we will do the plus by 1 again. But after this one, oh, it drops again. Then, yeah, after we have 3 times of increment, the stock is decreasing again. So using this value, okay, so using this S value, we can determine if it is increasing and it keeps growing, okay, maybe the stock is good. Okay. But when it drops, so this stock is very risky or dangerous. So using this kind of analysis, how can we use stack to understand this one? So there is one algorithm called span 1. So using the span 1 algorithm, we will give the input array, and there are n integers. Okay. So this is the array. So we have 6, 3, 4, 5, 2. So this is, for example, the price of stock. Okay. And then we need to get this output. So this output will be the span. We call it, this is a span, to understand whether the price is rising or dropping. So the output will be an array of S and a span of X. So S is a new array of n integers, and then we will do loop. The loop will be from 0 until n minus 1, and let the S start from 1, and then check if S is less than the I, and Xi is less than, Xi minus S is less than Xi. So S means the index that we want to look and from 1 until the next one. Okay. If it is less than the I, okay, for example, this one. So if it is 6 and then 6 compared to 3, okay, then okay, we will just use 1. But now 3 is less than 4, then S will be added by 1. 4 is less than 5, yes, then 2 will be added by 1. So it becomes 3. So that's the idea, S plus 1. And then S is always checked with the I. And then, yeah, we will put the value of S into the big S, which is the array of the span. If you do this one, okay, so it will use 2 for loop. Okay, we will use 2 for loop. The first for loop will go from index 0 until n, and then for this while, yeah, it will check for every S from 1 until I. Okay. What is I? I is starting from 0 until n. Then I can say this one will be like from 0 until n. So this is n and this is n. Yeah, this is the number of operation. Okay, that will be from 1 plus 2 until n minus 1. Because this is n and this is another n, so the algorithm spans 1 runs in O n power of 2. Okay. So the same with the quiz. Okay, in the quiz, whenever we have for loop, whenever we have one for loop, it will always run n times. Now, if we want to use stack, how can we use stack? Okay. So the stack is, how can we use every index of the element and then looking back. So the algorithm will be like this one. We scan the array from the left to right, and then let I be the current index. We pop the index from the stack until we find the index j such that the xi is less than xj. And then we will set the si equals to I minus j. And then put again the x into the stack. So maybe for the easy understanding, we can just use this pseudocode. Okay. So this pseudocode means in the span 2, okay, we have the same, which is S and then A. So let's suppose A is the empty stack. So it will trace for every number. So S is the span. Okay. We will do from 0 until n. Okay. But now, instead of doing the while from the S equal to 1 until n, we will just check the stack. If the stack is not empty, okay, so this symbol is not, yeah, the meaning is not. And then if the top of the stack is the index of the top less than equal to the index of I, so it's just removed. Okay. And then if it is empty, then let's just start with the I plus 1. If it is not empty, then I will be minus with the top. And then again, after you finish with this one, push it. Based on this algorithm is to check only one, which is the top. So it means every time we want to check whether it is empty or the top is less than xi, and then we pop. So this operation is only one time. Okay. And if there's still the top, okay, then we again pop. And usually it will not do until n times, but it will just do for yeah, if the top is keep growing, okay, for example, okay, this one, after we have this number, so after we finish the top, okay, we know that this is the top, and then we will drop again. So because this is less than this one, then we will pop or we will remove, and then we will make the new span which equal to 1 again. And then we improve, and it will be renew the top, and then we go here again. So we will just pop, and then we will renew the top, and then this is the new top. So we will just remove the previous one and put the new top. Okay, and then because this one, oh, this is decreasing, so we will return back to 1 at this stage. So for every time we remove the stack with the new one. So by using that kind of thing, yeah, we can get linear algorithm. So every time we remove the stack, yeah, it will just only one operation. And it will do for every element in the array until the end. So that's why the span 2 will run ON. Okay, I think that's all about the stack. Okay, so we already learned about the abstract data types, and then we learned about the stack example, and how can the stack can optimize the algorithm. So if you go to the code, I give you the code for the span 1. So this is the span 1 algorithm, and let's suppose you have the span, it is a list. So the first element is 6, so it starts with the s equals to 1, and then the next is 2, because it is a drop. Okay, so the value drops to 2, so it starts with 1 again. It increases, so now the value becomes 2, and then it increases, now the value becomes 3, and then it drops again, so its value becomes 1. Now, how if we change the data structure from this n power of 2 into linear with stacks? So I can say this is, yeah, O n power of 2. And this is using stack. Okay, so the use of stack will try to remove the stack whenever we have a new value that is higher than the previous one. Okay, so here if the top is less than the new value, then just pop. Okay, and then append into the sorry, this one you can just append into the stack. Okay, so this will show you the same result if you have this input 62452. Yeah, it will show the same result. This is 1 1 2 3 and 1, and this algorithm will work with O n because stack is always doing only one operation. Okay, so any questions?